So in the lesson gravitation, we have seen the universal law of gravitation and its mathematical formulation. So what does the universal law of gravitation state? The universal law of gravitation states that every object in the universe attracts every other object with a force which is directly proportional to the product of their masses and inversely proportional to the square of the distance between them. So, we considered one example. We considered two objects of masses m1 and m2, and from the universal law of gravitation, we found out the mathematical formulation of the universal law of gravitation as F is equal to capital G into m1 into m2 upon d square. This we have seen already earlier. You have already taken down these notes. Okay, so F is equal to capital G m1 m2 upon d square, where capital G is universal gravitation constant. And this universal gravitation constant value also you have seen, that is capital G is equal to 6.67 into 10 raised to minus 11 kg. Okay, what you can say, Newton meter square per kg square. Okay, that's what we have seen. And now we will see today the importance of the universal law of gravitation. So the importance of the universal law of gravitation is like this. The universal law of gravitation explains the force that binds us to the earth. First, it explains the force that binds us to the earth. Second is it explains the motion of the moon around the earth. So it explains the motion of the moon around the earth. Third is it explains the motion of planets around the sun. So it explains the motion of planets around the sun. And fourth is the tides in the sea which are formed due to the moon and the sun. So these all things are explained by the universal law of gravitation. So what all does it explain? First is it explains the force that binds us to the earth. Second is it explains the motion of the moon around the earth. Third is it explains the motion of the planets around the sun. And fourth is it also explains about the formation of the tides in the sea due to the moon and the sun. So this is about the importance of the universal law of gravitation. Now we will see what is the meaning of free fall. Now free fall means when an object is falling to the earth only under the action of gravitational force, it is said to be under free fall. So what is free fall? When an object is falling freely to the earth only under the action of gravitational force, then it is said to be under free fall. That is, it should fall freely to the earth. Okay, and it should not even experience the friction due to the air. Then only it is said to be under free fall. If there is air, then there is every chance that it will float in air also. Isn't it? So it is said to be under free fall only when the object is falling down to the earth, okay, under the action of gravitational force and no other forces at all. Okay. Now, whenever an object is falling down, okay, from a particular height, whenever an object is falling down to the earth from a height, then what happens is it experiences some force acting on it. That is the gravitational force acting on it. Its velocity goes on increasing. Its speed goes on increasing. Because its speed goes on increasing, it will be under acceleration. And this acceleration is caused due to the gravitational force. And that is why we call this as acceleration due to gravity. We call this as what? Acceleration due to gravity. And acceleration due to gravity is denoted by small g. Okay, so acceleration due to gravity is denoted by what? Small g. So, what is acceleration due to gravity? when an object is falling freely, that is, it is under free fall, it experiences acceleration. And this acceleration is due to the gravitational force of the earth. Since this is because of the gravitational force of the earth, we call this acceleration due to gravity, and this acceleration due to gravity is denoted by small g. It is denoted by the letter small g. So what is free fall? If an object is falling down under the action of only the gravitational force and no other forces at all, it is said to be under free fall. And whenever an object is falling freely from a particular height, from some height, then it experiences acceleration. That is, its speed goes on increasing. And this acceleration is due to the gravitational force. That is why we call this acceleration as acceleration due to gravity, and acceleration due to gravity is denoted by small g. Now let us derive the expression for acceleration due to gravity and then calculate its average value. For this, let us consider an object of mass m falling to the ground. So let us consider an object of mass m falling to the ground. Now, then by second law of motion is what? F is equal to ma. From second law of motion we get the force acting on the object will be F is equal to m into g. What is small g? Small g is acceleration due to gravity. Let us mark this as equation 1. So we have considered an object of mass small m falling to the ground. Then by second law of motion, the force acting on it is F is equal to mg. But by the universal law of gravitation, the force acting on it is given by F is equal to gmm upon d square. What is capital M? Capital M is the mass of the earth. D is the distance or height of the object or distance of the object from the center of the earth. Small m is the mass of the object. Capital G is universal gravitation constant. And the value of universal gravitation constant we all know. That is capital G is 6.67 into 10 raised to minus 11. Newton meter square per kg square. And if the object is in the earth's atmosphere, then the height of it will be very less as compared to the radius of the earth, because radius of the earth is very, very large. As a result, approximately d becomes equal to r. Whenever the object is in the earth's atmosphere, d becomes equal to r. R is the radius of the earth. So this equation becomes equal to F is equal to gmm upon r square. So see once again, whenever an object is falling down in the earth's atmosphere, then the distance of the object from the center of the earth, it becomes equal to the radius of the earth. So d becomes equal to capital R. So F is equal to gmm upon d square becomes F is equal to gmm upon r square. Because if the object is in the earth's atmosphere, then d becomes equal to r. Now mark this as equation 2. From equation 1 and 2. Equation 1 is what? Equation 1 is the force acting on the object due to the gravitation of the earth, that is F is equal to mg. Equation 2 is also the force acting on the object due to the earth's gravitational force. Both are one and the same. So let us equate them. So mg becomes equal to gmm upon r square. Mg becomes equal to gmm upon r square. On both sides you can cancel small m. So on both sides if you cancel small m, what you get is g is equal to gm upon r square. Now this is the equation for acceleration due to gravity. Small g is acceleration due to gravity. And if the values of capital G, m and r are substituted here, That is, if the value of capital G is 6.67 into 10 raised to minus 11, capital M is mass of the earth, small m is, sorry, capital M is mass of the earth, capital R is radius of the earth, then what we get is the average value of small g is 9.8 meters per second square. So acceleration due to gravity we get g is equal to 9.8 meters per second square. Okay, now you all can take down all these notes and write down these notes in your fair. Okay, learn and practice them. Okay.